Welcome to Study Loop.
We need to find the equation for the span of a cable, knowing that there is a tension of Tm on it that must not exceed some value. And I went ahead and drew out a free body diagram of some arbitrary cable. So I'm going to start by writing out the equation for the length y of b. And we know that that's going to be equal to the length c times the hyperbolic cosine of L over 2 divided by c. And we can also write that the tension Tm is equal to the weight per unit length of the cable times the length y of b. So we can then write this as W times C times the hyperbolic cosine of L over 2 divided by C. And we're then going to write this as W times L over 2 times 2 over L times C times the hyperbolic cosine of L over 2 divided by C. And the reason we did this here is because we're gonna let some variable z be equal to L over 2C. And we do this so we can take a derivative of this equation and help solve for minimum value of Tm. So that's why we insert this L over 2 and 2 over L here. So we let z equal this expression here. So we can then rewrite Tm as W over L, W times L divided by 2z, 2 times z, times the hyperbolic cosine of z. And we're now going to take a derivative of this equation. Take the derivative on both sides. So we take a derivative of Tm with respect to z. So that's now going to be equal to W times L divided by 2 times z and then times the hyperbolic sine of z minus 1 over z times the hyperbolic cosine of z. So in order to find the minimum value that T of m has to be, we need to take this derivative here and set it equal to 0. So we're going to set this equal to 0. And we're going to simplify this and rewrite it as the hyperbolic sine of z is equal to 1 over z times the hyperbolic cosine of z, which we can then rewrite as the hyperbolic tangent of z is equal to 1 over z. And then we take this equation here and we can solve it for z. So solving for z, we'll find that z is equal to 1.1997. So we can take this value for z and we can plug it back in to this equation here. So we can plug it into this equation here. And we can solve for an expression for L. So we get that the tension Tm is equal to W times L over 2 times the value that we plug in, this value of Z, times the hyperbolic cosine of that value of Z. And then we take this equation here and solve it for L. So we rewrite it solving for L, and we'll get an equation. So I'll write it in black. So we take that equation, solve it for L, and we'll get an equation L that's equal to 1.3255 times the tension Tm divided by the weight per unit length. So we're now going to use that equation to solve for a value of L using the given values. So we're given a weight per unit length of 0.25 pounds per feet. And then we're also given a tension that's equal to 8,000 pounds. So we just use this equation and we plug in the given terms. So L is going to be equal to 1.3255 times 8,000 divided by 0.25, and that will give us a length that's equal to 42,416 feet.